I go by JD, but my full name is Juan David Diaz Villarreal. We got Professor Ishmael Goins. This is English 111. And I created this slide the 27th of November 2022. The topic I chose is how neuroengineering treats neurological disorders/diseases. The initial focus that gravitated me towards this is that I have friends and family members that have gone through difficult times because of neurological disorders. So it inspired me to seek this topic and find innovative solutions. You may wonder, what is neural engineering? Neural engineering is the application of neuroscientific and engineering approaches to understand, repair, replace, enhance, or exploit the properties of neural system, as well as to design solutions to problems associated with neurological limitations. Right here we have a small image of a neuron. Basic parts is the dendrites, that is pretty much like the hair. We have the axon, that is like the body of it. The myelin, that is like the muscle of it. Now we have Lionel Messi, future World Cup winner, this cool dude, and this weird-shaped arrow, wondering, how is this research relevant to scholars and the general public? Let me tell you that there is a lot of people being affected by neurological disorders worldwide. We're talking about millions. And there is actually a study by WHO, and you may wonder, who is WHO? Well, WHO is the World Health Organization. They stated of 1 billion people affected worldwide, 50 million suffer from epilepsy and 24 million from Alzheimer and other dementias. To put it into perspective, that's larger than the entire nation of Italy, being 60 million people according to worldometer.info. You most likely heard these words before. Epilepsy is a condition with recurrent seizures. And there are different types of seizures. Some of them are like really hard. Some of them, you may not even notice they're having seizures. They just have like this, and that's it. It's pretty extensive. We have Parkinson's, Alzheimer's. We got prosthesis, which is an artificial body part. And this is used interchangeably with prosthetics, which is not the same thing. Prosthetics is the field that is in charge of engineering these prostheses. We also have tremors. That's what a Parkinson's disease patient undergoes. They are involuntary quivering movements. Then we have sclerosis. That means abnormal hardening of body tissues. So now, how bad are neurological disorders and who is being affected? So therefore, I got a video to show you.
I live with young onset Parkinson's disease, a chronic neurodegenerative disease that's progressive and incurable at this time. Parkinson's disease causes physical changes, emotional changes, mental changes, and social changes, and it affects every aspect of your life. We don't have control over our diagnosis, but we do have control over how we face the challenges that this disease brings into our lives. That's very important. Self-care is also very important in terms of optimizing your nutrition, your exercise routine, your sleep routine, and stress reduction, and socialization as well. Brain health is everything. It determines how you are physically, mentally, emotionally. It governs your social relationships, and it, in fact, optimizes your quality of life. Without good brain health, there is no good quality of life.
So going back to the question, how bad are neurological disorders and who is being affected? First of all, there's millions of people being affected, and you can tell she had tremors. She couldn't start quivering. Her quality of life is not as good as ours. And most of the time we take it for granted when we should really not. Now, we come to the good part, the solutions. There is more of them, but these are more advanced or more technological in a way. So we have neural processes, such as brain-computer interfaces, or the abbreviation for it, which is BCI. We got BCIs here, and we got neural stem cell engineering. What is this? This is fundamentally done to people that undergo multiple sclerosis, and they go through regenerative therapy. The purpose of this is to restore myelin, which is part of the neuron that we saw earlier. Now we have the second, brain-computer interfaces, or BCIs. Right now it may not be too famous. Even Elon Musk, he co-founded a company called Neuralink years ago that you may not even know about. It's basically to research this. Right here we have an EEG. It's multiple of them, right? And you put them on your scalp to read your brain activity. Under the scalp, we got the soft tissue. Then we have the skull, then we have the dura, and then the cortex. And as you can tell here, there is some red spikes. This would be the brain-computer interface, or the BCI. The spikes are called electrodes. And on the second graph, we can see how this would work. So you have that implanted in your brain. I know it sounds a little scary. We're gonna get to that part later. And basically this gets the signal acquisition, the feature extraction, the feature translation, and then the commands. And in the third graph, which is not really related to the topic, but it's worth noting, it actually works as a bridge for people that have amputations or that don't have a limb. and you could basically control with your brain artificial processes. In a more related way, this helps epileptic people. Epilepsy mostly happens when there is an overcharge or an overload of neural activity. The BCI would read if there is too much activity going on, it would act on it, preventing seizures. So imagine someone that has recurrent seizures, and when you have a seizure, you lose consciousness. Your memory doesn't work as well. This will most likely help a lot of people, epileptic people, Parkinson's disease victims, etc. Now we come to a good part of it, that is the repercussions of neurological engineering. So you may ask, are we playing God when we're doing this? Who gives humanity the right to improve illnesses? Aren't illnesses a way of God punishing the sinners? From a religious perspective, for instance. This was made by BCI Medical Ethics. They conducted 9 semi-structured interviews with BCI users, and the result is that the benefits outweigh the risks. And as in everything in life, there's risks. Worst case scenario is death. But best case scenario, you cure an incurable disease. Maybe people who don't undergo these situations may be more skeptical about it, but people who are being affected by neurological disorders such as epilepsy, Alzheimer's, etc., are willing to take these chances to enhance their quality of life to a great extent. We have participants, we have the name of them, their age, their diagnosis, the regular technologies they use, and then the BCI technologies they use. And there is a relation between how severe their condition is and how many training sessions they had to go through. So now we have the outlook for the future. A lot of people are being affected, as I said earlier. That means less productivity for themselves, less happiness in a way for themselves and for society. So if these people can be cured, that means a country can be more productive. They can be more productive. They can do more things regular people take for granted. And the objective of this is to raise awareness. Really look out for this, because this is going to be more implemented in the following decades. This is my works cited. Thank you very much, guys. The video may look choppy due to cutting of clips to make the video shorter and more attention grasping. In association with Andrew Libman, Instagram Andrew's Aerials.